A stable grasp is often not enough for the manipulation task. Semantic grasping addresses this problem by selecting a stable grasp that's suitable for the task. Existing works grant semantic grasps to low-level features. However, the large variance in these features prevents generalization. Other works define semantic grasp with handwritten rules, but manually specifying rules is not scalable. In this work, we leverage semantic representations and apply the wide and deep neural network to learn grasps from data. Using RGBD image of the scene, affordance detection simultaneously detects the object and segment the object based on affordance. Spectral reading of the object is then used to classify the object material. Given a task and the state of the object, for each grasp from the sampled stable grasps, all the extracted semantic information are fed into a wide and deep neural network. The wide component of the network takes in sparse features and uses a linear model to capture the complex reasoning patterns. The deep part maps these features to dense embedding vectors to promote generalization. Pooling is also used to create an object embedding based on all object parts. Together, these embeddings are passed through multiple fully connected layers. Combining the wide and deep part, the network is able to predict the suitability of the grasp. The system then iterates predictions for all grasps. Finally, the robot executes the grasp with the highest score. In addition to the comparison with existing methods reported in the paper, we have conducted 32 tests on the real robot. Examples of the tests are shown here.